Hello, a very warm good evening to all of you, and welcome to Unacademy. Welcome to our NCERT series, where we have completed the portion of geomorphology as per the basic NCERT, that is the fundamentals of physical geography for class 11th. And we have covered it in as much detail as it is required for the examination. Today, we embark upon the journey for climatology. Now, climatology forms the most important part of your entirety of geography. If you have to consider physical geography, the Indian geography, world geography, any portion of geography, the most vital and the most conceptually relevant portion is your portion of climatology. UPSC does ask you questions from climatology, not only in the prelims as well as the mains examination. And this is where you have the scope to create a difference as compared to your competition. Those people who are weaker in concepts, they are never able to cover the portion of climatology. It is here, if you develop the deeper concepts, if you analyze and understand it in as much detail as required, then you will always end up gaining more marks, both in the prelims, also in the mains exam. Now, climatology in itself is basically composed of variety of various different chapters, from the portion of your atmosphere to the case of air circulation, the cyclonic structure, everything is included in climatology. Now, today, we are going to start with the basic, that is atmosphere. And this is where will lie the foundation for the remaining chapters to come. All of you who are weaker in climatology, or if you find yourself not to be very strong in climatology, please revise this portion. The rest of the chapters automatically become easier. Mains type of questions are also asked from this. Now, what we will also be doing from next week is, with the hope that you would have revised the previous modules, from next week onwards, we will also be discussing some of the mains questions and discussing about how to write answers. Especially for those of us who have never written the answers, I will give you a kind of a model of how to create an answer, what is expected out of a candidate in answer writing. Okay. Now, here, basically, we start first of all by taking a look at the case of the previous year question which was asked. The question was asked in 2024 itself. Now, it was about the layer of atmosphere. Now, we will discuss this question as is the case at the end of the session. Now, before that, some of the practice MCQs, just to see whether we have revised our overall portions or not. Let me know about the answer in the comment section. Starting with the first question. Consider the following statements regarding weathering and erosion. Weathering always precedes erosion. Weathering is an in situ process, whereas erosion involves transportation. Significant erosion can occur even in the absence of prior weathering. Which of them is or are correct in this particular case? Let me know here. Okay. So basically, weathering always precedes erosion. That is incorrect, right? So one is incorrect. We know for sure. Eliminate one. Weathering is an in situ process, that it happens in that region itself, whereas erosion involves transportation of materials from one region to another. This is going to be correct, isn't it? Transportation of materials. So erosion is materials are removed from one place, deposited to another place. Significant erosion can occur even in the absence of weathering. Now, this is the contentious statement. What do you think? The answer will be, can erosion happen even in the absence of substantial amount of weathering? The answer is yes, it can. So here, erosion can happen even in the absence of weathering. If, let's suppose, you have force of nature, which basically comes to a region, let's suppose you have a larger rock, and you have a larger river or a glacier which is moving, it is not necessary for the rock to be broken. It is something which basically it can shave off this rock and then can take it away. It can be inferred from the first statement as well. So the correct statement is going to be C. That is 2 and 3 only. Consider the following statements. Physical weathering generally increases the surface area available for chemical weathering. Chemical weathering becomes more effective where water and heat are available. Mechanical weathering cannot occur in humid climate. Now, which of them are correct? Yeah, rock beneath the waterfall is also the case. Yes. So this is a simple question. I hope that everybody is able to solve this. So physical weathering generally increases the surface area because even if there is a granular disintegration, block disintegration, any kind of breakage, the surface area increases, whereby after that they can be exposed to oxygen, carbon dioxide, and you can have more chemical weathering. Chemical weathering becomes more effective where water and heat are available. That is true. Reaction becomes accelerated in this case. Then mechanical weathering cannot occur in humid areas. This is an absolute statement. In humid areas, the kind of weathering which generally predominates is your chemical weathering in humid areas. Okay, that is the kind of weathering which is very dominant. So here, mechanical weathering will also occur, but humid areas are dominated by chemical weathering. Okay, by chemical weathering. Okay. Now, so the correct answer is going to be A, 1 and 2 only. Now, consider the following statement. Subduction requires a density contrast between the converging plates. Continental crust generally resists subduction because of its lower density. Oceanic trenches are always found adjacent to continental margins. Which of them are correct in this case? This is about plate tectonics. Humid region, the region, Mohammed Alamgir, the humid region is that region where you have lot of rainfall which occurs. In yesterday's class, we had discussed day before yesterday's class that how rainwater combines carbon dioxide, oxygen, etc., and then creates degradation. So it is the follow-up to that itself. So subduction requires a density contrast between the converging plates. This is going to be a correct statement, isn't it? Basically you will have that subduction is always there whenever you have the oceanic place. That is where subduction is majorly present. So always oceanic crust is of greater density, right? Continental crust generally resists subduction. We have seen with the help of animation also that how continental crust basically they will start to accumulate and they will start to get folded rather than undergoing subduction. So this is also correct. Oceanic trenches are always found adjacent to continental margins. Now, is this correct? The answer is no. When you talk about Mariana Trench, for example, Mariana Trench is not next to a continental margin. Java Trench, Sunda Trench. So Java Trench and Sunda Trench situated in this area, Mariana Trench situated in this area, they are not next to a continental margin. It can be in the case of oceanic as well. So the correct answer is B, 1 and 2 only. Consider the following statements regarding glacial depositional landforms. Moraines consist of unsorted glacial debris. Drumlins indicate the direction of former glacial movement. Which of them are correct? Unsorted basically refers to which is not structured, mixed. That is what is referred to by unsorted. Okay. So in this case, both the statements will be correct, and the correct answer is going to be C. Now, those of you who, let's suppose, are not able to solve these questions, maybe because you have not covered those portions in the earlier lectures. A gentle request, don't keep that pending. That one fine day when I will get free time, then I will look at those recordings and I will take a look at those videos itself. That fine day never comes in the life of a civil services candidate. Never will you get so much time that you will cover all the previous portions. So do it now itself. Otherwise, if the pending portion is left uncovered, that will be a problematic area in the days and the months to come. And that will be a weak area where you will never gain confidence. So cover it as early and as soon as possible. Now, we initiate the chapter of climatology, but before that, an announcement for all of you. Now, Iconic Pro is a product offering that we have where you get unlimited mentorship with the qualified mentors who have written the mains examination, appeared for the interviews, and also you get one to one guidance with your educators as well. Now, accordingly, you get a help and idea in terms of formulating your strategy. For example, someone who has, let's suppose, already prepared the GS, not prepared for optional. Now, their strategy will be very different as compared to someone who is an absolute beginner. When you initiate the preparation, how to cover current affairs, which area to focus upon. So that is basically where you can avail this Iconic Pro, and you can have the one-to-one mentorship via the top educators, the educators that you want. Use the code IS English, access to 12 plus optional subjects, and basically you can upgrade as well. So you basically will have the video mentorship with the educators every 15 days. If you, whatever your current plan is, now with small amount of payment, you can upgrade to Iconic Pro. You can contact this number for any kind of query that you have. Now we come to the portion of climatology, and the first chapter that we talk about, we initiate the discussion about, is the atmosphere. Now, atmosphere, the image that you see on your screen, is an envelope of gas which surrounds the Earth's surface. Now, this atmosphere basically is the provider of life on planet Earth. Had this atmosphere not been there, life would never have been sustained on planet Earth. So that is why atmosphere is of vital importance. Now, when you take a look at the entire lit up portion here, you're not able to see the ground, by the way. The portion which is lit up, that is your atmosphere. Now, this atmosphere basically, you will observe that is quite thick, right? Can extend up to thousands of kilometers. But then the gases that you have closer to the Earth's surface, it becomes very different, very thin as you move higher up. This atmosphere has also got layers, and you are surrounded by air and you cannot feel that air. For example, that room that you are sitting in right now or sleeping in right now, you won't be able to feel the air with your hand. But let's suppose you switch on the fan, then the air starts to move. That is when you are able to feel the air. So you are able to feel the movement of air. Now, this atmosphere is responsible for almost anything and everything that you see around yourself. The plants that grow, the types of rainfall that you receive, everything is determined by the atmosphere. That is why climatology becomes that very important for you. I hope you are aware. It is climatology greater than geomorphology. Obviously, climate of a region is determined by the landform. So, geomorphology determines the climate, but it is the climate of a region which ends up determining multiple political and social outcomes of a place. For example, in history, you study about the advent of Europeans, the colonization of Asian countries, and colonization of the world by the European powers. You talk about the advent of Europeans into India. Now, have you ever thought about it? That why is it that the Europeans were interested in India? The popular rhetoric is because we were very rich, and that is why they came here to plunder us. But then For the first time that the Europeans came to our doorsteps, for the first time that the Romans came to our doorsteps, they did not come to us in order to plunder. They came here. Why? In order to trade. And what is it that they were so interested in that we had that the region of Europe did not have? We had the presence of pepper, spices. And why would they need those spices? Is that because the English food is very bland? While the reality is that the English food is very bland. But then the climate of Northern Europe would be such that nothing would be growing for the winter months because the winter would be covered in snow. The ground would be covered in snow. So, in those barren conditions, they had to preserve their food, they had to preserve their meat. And for that, the best preservative, natural preservative available was pepper. That is why Vasco da Gama, when he went back, even after all the expenses of this costly trip, when he sold the spices and the things he got from India, he generated profit which was more than 20 times. That is how important this pepper was. And now, when we are talking about things like pepper and spices, why do they grow in India? Is it because we are very good people? No, because the climate determines so. So that is how important climate is. You had an American geographer, the name of Ellen Churchill Semple. Ellen Churchill Semple was a geographer who was very ambitious. She wanted to study the world. When she studied the ethnic and the racial traits of population, she had an observation about India. She said that, look, the Caucasians or the Europeans, they have very strong legs because they have to frequently climb up the mountains and come down. The Africans, they have broad shoulders and they have a strong body because they had to carry logs of wood through the dense forest. And when she talked about the Indians, she said that Indians, they do not have very great physical traits because Indians never had to worry about food. Our climate is such that every season something or the other will grow. We will have the availability of food with us. And that is why Indians, they are not gifted physically. And that is where they are very gifted mentally. Now, this is considered to be one of the great insults to us Indians. But nonetheless, that tells you about how climate and atmosphere has been particularly kind to us as compared to many parts of the world. That is why study of climatology begins with atmosphere. Now, when we talk about this atmosphere, atmosphere is constituted by what? So you have three major constituents of atmosphere. First is the presence of gases. Now, which are those gases? Now is not the time of your life to ratify the percentage of nitrogen, percentage of oxygen, etc. Still, I will give you that number, but you are past that stage now. But basically, these gases include what? Nitrogen, oxygen, argon, carbon dioxide, etc. Right? Hydrogen to some extent. All of those gases are present. Now, these gases, they provide us with life. Oxygen provides us with the respiration ability. Carbon dioxide allows the plants to carry out photosynthesis. Nitrogen allows for certain plants to carry out their developmental growth. Other than that, gases like ozone in the atmosphere, they protect us from the harmful ultraviolet rays of the sun. So gases are very, very vital, by the way. Now, the gases play another role, and that is the role of the greenhouse effect. Greenhouse effect. What is that greenhouse effect? Let's take a look at it with the help of an animation very shortly. But then, other than gases, another gas, it is a gas itself, but water vapor. Now, water vapor is another major constituent of the Earth's surface, of the atmosphere. The clouds that you see up in the sky, the rainfall that you receive, the cyclonic formation, the tornadoes, the hurricanes, everything is controlled by the amount and the presence of water vapor up into the sky. Now, if let's suppose by some artificial power that uh, the nature bestows upon you, right? Let's suppose you have supernatural power. If you condense all the water vapor in the atmosphere, it will cover the planet in a very thin layer of 1 inches or even less. So that tells you that water vapor in the atmosphere is not extremely high. It is present, but in limited quantity. And that too, it is present in the lower elevation and at the lower levels of atmosphere. But this water vapor impacts the climate also in the form of rainfall, cyclones, etc. It also creates the greenhouse effect. And then the third major component of the atmosphere is the presence of dust particles, which regulate the climate, which lead to the cloud formation, which eventually also end up allowing us to see during nighttime by emitting what is referred to as diffuse light. Okay. So that is basically the three constituents or the three components of the atmosphere. Let us take a detailed look at each one of them, starting first of all with the gases. Now, here, one of the basic mistakes that majority of the candidates do is they feel that the proportion of gases highest amount nitrogen, then comes oxygen, then comes carbon dioxide. It is not so. Okay, so the most dominant gas in in our atmosphere is nitrogen. Now, then comes oxygen, then comes argon 0.93. Okay, and then comes carbon dioxide 0.04%. Now, we have seen in the earlier sessions that atmosphere was not always like this. You had a greater portion of Earth's history when oxygen was not even present. Carbon dioxide was very dominant. Why did the proportion of carbon dioxide reduce and the proportion of oxygen increase in the atmosphere? This was basically because of the evolution of plants. Plants carried out photosynthesis, and that photosynthesis created the oxygenation events whereby they consumed the carbon dioxide and released oxygen. So that is why basically you had photosynthesis and evolution of species responsible for this. But why is nitrogen present in such maximum amount? Why not any other gas? Why don't we have oxygen as maximum if the plants are so powerful? Why don't we have oxygen as the most dominant? Why only nitrogen? The reason is very simple. Nitrogen was introduced into the atmosphere in which phase of planet Earth? Correct, Pratibha, that is true. Nitrogen was introduced into the atmosphere in the phase of degasification. Phase of degasification. That is when nitrogen was introduced. Now, nitrogen exists in the form of a triple bond structure, and that is considered to be a very stable structure, and a stable state. This is why nitrogen is non reactive almost to the other different components on the earth's atmosphere, even in the case of the earth's surface. This is where the derivation and the linkage comes in. And understand this. See, oxygen, for example, when it is present in the atmosphere, it does react with the rocks, forms oxides. Carbon dioxide does react with the rocks, forms carbonates. For example, when the planet Earth was evolving around 90 to 95 million years ago, a series of volcanic events covered the entirety of planet Earth. Such huge amount of lava and gases came out that the atmosphere was dominated by carbon dioxide. Oxygen quantity reduced, and so much amount of carbon dioxide was there that basically the planet started heating up due to greenhouse effect. The planet's temperature increased. Many of the species went extinct. It is at that point of time when it is said the ancestors of the blue whales, even they went extinct. But while all this was happening, how did the planet come back to normalcy? Over a period of time, in the tropical region that is closer to equator, the trees started absorbing these carbon dioxide. Their rate of photosynthesis increased, so the growth of the trees increased. The process which UPSC had asked in the prelims in environment and ecology, what is known as carbon fertilization, whereby the increased amount of carbon dioxide in the atmosphere increases the growth of biomass in the trees. So that absorbed carbon dioxide. Carbon dioxide was absorbed with the rainfall, formed carbonates. Carbon dioxide was absorbed by the rocks, formed carbonates. Eventually, over a period of 10 to 15 million years, proportion of carbon dioxide across planet Earth reduced. And that is when oxygen started going back up and the temperature became tolerable across planet Earth. So these gases have been changing, but nitrogen remains consistent. Why? Basically, because nitrogen is non reactive. It is this reason why the nitrogen does not react with the rocks. And because it does not react with the rocks, it does not form any of the nitrate compounds in the rocks. Rocks will have carbonates, oxides, etc., but not nitrates. Now, what is the implication? A couple of classes ago, we saw that these rocks eventually weather down, get eroded, break down, and then they get converted into soil, isn't it? Now, if the rocks don't have nitrogen, will the soil ever have nitrogen? No. That is why majority of the soil types across the globe, they lack nitrogen. And that is why one of the most predominant fertilizers used in the entire agricultural and the farming sector is urea, that is nitrogen based fertilizer. So, this tells you how atmospheric gases end up eventually determining the type of soil that you get and your agricultural practices as well. Okay. Now, this is basically about the gases, but here you should be aware about nitrogen, oxygen, argon, then carbon dioxide. Carbon dioxide is 0.04%. Now, these gases, many of these gases, they create what is referred to as the greenhouse effect. Now, what is a greenhouse effect? So, basically, a greenhouse effect is the trapping of the heat by the atmosphere. You see, what happens is that the sun releases energy in the form of very high energy radiative waves, what is known as the incoming short wave. Incoming short wave, because the wavelength is small. Incoming short wave solar radiation. Okay. Now it heats up the planet. It heats the planet's surface. The surface then again starts behaving like a hot object. Then the planet starts radiating its own heat, but of lower energy. Obviously, planet Earth will have lower energy as compared to the sun. It will radiate its own heat with a lower energy, what is known as outgoing long wave terrestrial radiation. Terrestrial radiation. Now, when this happens, basically, this low energy wave emitted from the Earth, ideally, it should escape into the space. But this gets trapped by the atmospheric gases and heats up the atmosphere substantially. And that is what is referred to as the greenhouse effect. So, greenhouse effect is the trapping of the heat and increase in the overall temperature. So, understand this in various different stages. First stage, basically, what is that? Solar radiation reaches the Earth's atmosphere. Some of it can be reflected back into the space, but it hits the ground surface. Then the rest of the sun's energy is absorbed by the land and the oceans and creates the heating of the land, heating of the oceans, right? Temperature increases. Now, heat radiates from Earth towards the space in the form of long wave terrestrial radiation. Now, some of this heat is trapped by the greenhouse gases in the atmosphere, which keeps the planet warm enough to sustain life. Now, human activities such as burning of fossil fuels, agriculture, clearing of land, etc., increases the greenhouse gas concentration, due to which more heat is absorbed day by day, what we refer to as global warming. And that is where extra heat is being trapped, which is increasing the temperature across planet Earth. This is what is causing global warming. Okay. So, this basically is the step by step process of your greenhouse effect. Okay. Now, when we talk about the case of the greenhouse effect, is it good or is it bad? Is it good or bad? So, in moderate amount, how the nature designed it, it is meant to be good. How? To be good. How? Basically, if you consider the planet Earth rotates and moves around the sun. The portion which is exposed to the sun will experience daytime. The portion which is opposed to the sun will experience nighttime. Now, if the atmosphere would not have been there, during the daytime, the temperature would have been very high. Not very high, but still high enough, around 20 degree, 30 degree, 40 degree, etc. But during the night time, temperature would have plummeted like what you have in the moon or on Mars, minus 180, minus 200 degrees Celsius. So, greenhouse effect maintains the temperature, maintains temperature during nights, okay, allowing for life on Earth. That is the role of greenhouse gas. Without it, average temperature of planet Earth would have been below the freezing point. This is where 2025 UPSC prelims question, UPSC has given a wrong answer in the answer key. We will discuss that once we complete this entire portion. We'll discuss that tomorrow. So this is basically why, if atmosphere would not have been there, no greenhouse gas. So without atmosphere, average temperature across planet Earth would have been below freezing point. So obviously, life would not be able to sustain itself in the kind and the variety that we see today. Okay. But basically, If you have excessive amount of greenhouse gases, then it leads to global warming. Okay, that is what is happening presently. Now, then the impact of gases. So, oxygen is vital for respiration, photosynthesis. Plants also carry out respiration, by the way. I hope we are aware that plants, they do not only carry out photosynthesis, they also carry out respiration. They regulate climate and temperature. These gases, including water vapor, CO2, absorbs that heat. Now, if it is heated only, then evaporation will happen, cloud formation will happen. Now, gases like ozone, they will basically protect us from the ultraviolet rays of the sun. Overexposure to ultraviolet rays of the sun can cause skin cancer, can impact the growth of the plants, etc. Then they drive weather and water cycle, maintain atmospheric pressure and stability. Gases like nitrogen and argon are very important in maintaining the natural pressure of air, and they enable various other chemical processes as well. So that is why gases are important. Now, the next major constituent of the atmosphere is your water vapor. Water vapor, while it also is a greenhouse gas, water vapor is also a greenhouse gas. So it also traps heat, but it drives the water cycle across planet Earth. It drives the climatic phenomena across planet Earth. So it regulates the Earth's temperature, first of all, by trapping the heat as a greenhouse gas. Then it basically drives weather and precipitation, like we have seen, transports heat and energy from lower latitude to higher latitude and vice versa, supports life. All the civilizations have basically grown up on the side of water bodies, right? Mesopotamia on the side of Euphrates and Tigris, Indus Valley on the side of Indus, Egyptian civilization on the side of Nile. So all the civilizations have basically grown up on the side of the river systems, influences the clouds, impacts air quality. If you have great amount of rainfall, air quality will be clean, right? Important in higher latitude for the temperature and the climatic control. Then you have the third constituent, that is your dust particle. Dust particle is also of vital importance. Many of the times dust particles, they contain certain minerals like iron, and those dust particles, when they fall on the water body, it allows for life to be sustained. But other than that, when we talk about these dust particles, they are suspended into the atmosphere. Now, these dust particles, they will basically trap the light and heat during daytime. Okay, so solar rays which come in, they basically get scattered and trapped in the dust particles. And eventually during night time, that light is visible to us. That is why, even in the darkest of the night, you don't go blind. You are able to figure out that, okay, this is a building, this is a road, even in the darkest of the night. That is because of the scattered light produced by the dust particles. Other factor here is, for example, now that the monsoon season is going on, a day when it rains a lot, when there is lot of rainfall, step outside your house or look out the window when there, let's suppose there's a power cut or late at night. You will be able to see lesser as compared to peak summer. Your visibility reduces in the days of excessive rainfall. Why? Because all the dust particles have been removed. So the scattered light has also been removed. That is when, if particularly in the forested areas, the visibility further reduces because the dust particle component is less. Okay. So that is basically where climate regulation, air quality, impact on oceans, providing life to various aspects. One of the important part is cloud formation. Dust particles are very, very vital for the formation of clouds. Okay, how? Basically, you have the concept of hygroscopic and hygrophobic. Okay, so when you have any particle which allows for absorption and allows for the sticking of water vapor, that is what is known as hygroscopic. So dust particles, they are hygroscopic. Hygroscopic, that is, they allow the water vapor to condense on them. If dust particles are not there, cloud formation will not happen, because for any condensation to happen, you need a surface, you need a platform that is provided by the dust particles. This is the reason when you talk about artificial rain, what do you do in the case of artificial rain? You basically spray silver iodide, etc., into the atmosphere. Why do you do so? So that that platform, hygroscopic platform, is provided for the water vapor to coagulate and accelerate condensation. That is what dust particle does. So dust particle is very vital even for cloud formation. Okay. Now, after that, now where do you get these dust particles? From the ground surface as a result of erosion, wind erosion, weathering. Let's suppose in the atmosphere, a meteor is coming, breaking down, burning out. That also creates the presence of dust particles. So all these, their processes, they produce a lot of dust particles. Okay. So next time when you talk about dust particles, it is not an absolute nuisance. There are benefits associated with that as well. Okay. Now, then after that, we come to the structure of atmosphere. Now, atmosphere is not uniform. It is not that the air that you breathe on the ground surface is the same air that you get 100 kilometers, 200 kilometers up in the sky. No. Atmosphere is very, very varied. Now, it is arranged into various different layers depending upon the air density, depending upon the temperature gradient, etc. Basically, up till the region of the mesosphere, still you will find that nitrogen concentration, oxygen concentration, etc., remains almost consistent. This is the case of what is referred to as homogeneous atmosphere or homosphere. Beyond mesosphere, that is thermosphere and exosphere, this is known as heterosphere. What do we mean by this? Heterosphere. It means at one place, let's suppose you will have only oxygen. At another place, let's suppose oxygen and nitrogen, nothing in between. Right? At one place, maybe another set of gases, nothing in between. So, like that, above mesosphere, you don't have a predefined or determined distribution of gases. That is why it is known as heterogeneous. Right? Which are the gases present in heterosphere? Here also, nitrogen, oxygen, etc., they are dominant. Along with that, hydrogen is also present. So, they are dominant there. Okay, but they are present in a very scattered amount. Okay, now you have 100-kilometer line division, what is also referred to as the Kármán line. Now, this Kármán line is basically used for aeronautical purposes. Even though the for as a layman, we basically say that this Kármán line is the difference between the atmosphere and the outer space. We say that. But beyond the Kármán line, it is said that the space begins and air is very thin, very thin. So troposphere is the air, basically the layer of atmosphere absolutely sticking to the earth's surface, right? Now, this is what we breathe in. This is where the cloud formation and the climatic conditions take place. Stratosphere, now it is a layer where you have the ozone layer, right? It is here that you have the ozone layer. Large commercial jetliners, they fly through the stratosphere, because in stratosphere you don't have vertical movement of air. Okay, so that is basically the case of the stratosphere. Then you have mesosphere, and beyond that, you basically have the case of thermosphere, exosphere. Outer limits of thermosphere, exosphere, not accurately known. Air disappears into the thin space. Listening the word Kármán line for the first time? Okay. See, Kármán line, the idea came from the case of the aeronautical engineers. I hope you are aware that when an airplane flies, denser air allows the airplane to get the lift. Okay, because as dense an air, the wings basically create a lift and the airplane is able to fly. So you need dense air. So that is where Carmen basically said that beyond the height of 100 kilometers, air is so thin that basically an aircraft won't be able to sustain the flight. It will fall down. It doesn't have the air to create that flight. So the aircraft will have to fly at supersonic speeds beyond that height of 100 kilometers in order to sustain the flight. That is where the name Kármán line was devised around half a century earlier. It is used by NASA for training the astronauts and is considered to be a limit for the outer space to begin. Okay. Turbulence generally occurs whenever you have upward and downward vertical motion of air creates turbulence always. Okay. Any place where, let's suppose, there is a sudden downdraft of air, the airplane will get a shift. Now, any place where there is an updraft of air, in that case, lift is suddenly provided. So that also creates a turbulence. So wherever you have high density, low density pockets of air, that creates variation in the lift of the airplane, and hence the turbulence is there. That is why you would have seen this. If you fly, you would observe this, that whenever there is substantial turbulence, generally the pilots, they put on a greater throttle, they accelerate through that region, because whatever lack of lift is provided by the airplane, they want to compensate that by the engine power of the aircraft. That is basically why in the troposphere, larger airplanes, they don't fly, because in troposphere you have lot of turbulence, in stratosphere less amount of turbulence. Okay, I hope that is understood. Now, when we talk about the troposphere, troposphere is basically not of a consistent height. The height of troposphere varies. At the region of equator, height of troposphere is the maximum. At the region of the poles, the height of troposphere is only around 8 to 10 kilometers. There are multiple reasons for this, why the height of troposphere varies. One of the major reason is that basically in the equatorial region there is so much amount of heat. Equatorial region means the region close to the equator. Okay, there is so much amount of heat at the region of equator that air heats up and rises up. We have studied in the case of the convection current that warmer materials, they rise up, colder materials, they sink down. So here, the air close to the region of equator gets heated and rises up. As it tends to rise up, that pushes the troposphere higher up. And in the polar regions, you have colder conditions, and then the air sinks down. Other than that, overall, the temperature of the atmosphere also is high in the region of equator. That also creates an expansion, right? Then you have the case of the shape of planet Earth. Shape of planet Earth is a geoid. It is not a perfect sphere. So when you consider the shape of planet Earth, it is a geoid. It is bulged around the equator. That means the gravitational pull of attraction, right? G1 is lesser than G, right? Because overall, the radius is more. So that is why the atmospheric air tends to swell up in this area. Okay. So why is troposphere? Why troposphere thicker at equator? Now, the reason, first reason, because of rising air at equator. At equator, right? And sinking air at poles. Sinking air at poles. So you have a lot of vertical movement happening in the region of troposphere. Secondly, you have the case of, when we talk about the case of the troposphere, at equator, these are the minor factors. Force of gravity is comparatively less. Gravity is comparatively less. As a consequence of that, expansion occurs. Okay. Then, other than that, G1, G not understood? Okay. We had discussed this in the first class itself. If this is radius R, R1. Okay. So when we talk about the radius across planet Earth, can we say R1 is greater than R? Can we understand that, Miraz? That basically at the region of equator, radius is slightly greater because Earth is not a perfect sphere. Earth is a spheroid, oblate spheroid, or a geoid. Okay. Now, when we talk about gravitational pull, right? Gravitational force. Now, gravitational force is what? It is basically inversely related to the distance. Greater the distance between the objects, lesser is the gravitational pull. If let's suppose I attach here the term gravitational pull as G and I attach here G1. So where will the gravitational pull be greater? Wherever the radius is lesser. So gravitation at poles is greater than gravitation at equator, isn't it? Which means the air will expand. Okay, right? Then you also have other factors such as the centrifugal force, etc. Why? Because you see, what is a centrifugal force? Any object which rotates in a circular manner tends to have a movement or a force acting on the outward direction. This is known as the centrifugal force. Any object. You take a ball, tie it with a string, and rotate the string. The ball will tend to fall on the outside. So that is basically your centrifugal force. Now, when planet Earth rotates on its axis, centrifugal force will be acting where? On the outside at the region of equator, right? So these are some of the minor factors again due to which the tropospheric height varies. Now, tropospheric height also varies from one season to another. For example, in winter season, whichever hemisphere you consider, in winter season, if the air is very cold, it will shrink. In summer season, if the air is very hot, it will expand. So there is a seasonal variation also, and there is a spatial variation as well. Then above the troposphere, you have the region which is your stratosphere. Now, stratosphere is the region where you have the ozone layer. Ozone is what? O3, right? Now, this ozone basically here, when we talk about the ozone, it traps the ultraviolet rays of the sun. So the ultraviolet rays of the sun, which are emitted, now those ultraviolet rays of the sun, they are absorbed here and they are sometimes re-emitted back. But most of them absorbed and some of them re-emitted back. Due to this factor, temperature in the region starts to increase. Temperature starts to increase. So in the troposphere, as you move higher up, temperature reduces. But in stratosphere, as you move higher up, the temperature tends to increase. Okay. So in troposphere, you will find temperature reduces with height. With height. Here, temperature increases with height. With height. Okay. Now, this is the basic kind of a difference. Now, this is one of the reasons why atmospheric air from troposphere will never enter into stratosphere. It remains slightly stable that way. That is why major and larger airlines will fly through the region of stratosphere. Then above it, you have the mesosphere. Here again, you don't have the ozone layer, so there is no heating. So here again, temperature reduces with height. Reduces with height. Okay. This is the layer where by the time that you reach the end of mesosphere, the temperature can reach minus 100 degrees Celsius. Okay, it gets very cold. And it is the layer where you will find that meteors, etc., all the celestial objects, they burn it out. Why? Because as they are falling through outer space, they don't get friction, they don't experience friction. But as they enter into the mesosphere, suddenly they experience a lot of air friction, and that is when they start to burn. Now, beyond the region of mesosphere, you have a region which allows for radio communications to happen. And that is the region of ionosphere, which is a part of thermosphere itself. Ionosphere is within the thermosphere itself. So, as you go up to that height, unadulterated, unfiltered rays of the sun. So, solar rays will have X rays also, UV rays also, everything. After all, ultraviolet rays will get filtered out only in the stratosphere. So, all these rays of the sun, they bombard the atmosphere. And when they bombard the atmosphere, that is when they will create charged particles, right? And these charged particles are known as ions. These charged particles are known as ions, and hence the name ionosphere. Okay. Now, in this ionosphere, what happens? If you consider this as the ground surface, you will have a lot of these charged particles. Okay. Now, these charged particles, they will reflect the radio waves. Okay. These charged particles, they will reflect the radio waves. So, the radio waves which are emitted, they get reflected back to the charged particles. And that is where it is this ionosphere which facilitates this radio communication. Now, this is the reason why many of the times during cloudy nights, etc., when you get the radio disruption, or basically you get the cross communication, why do you get so? Because imagine if there is a cloud cover here. Cloud also has got charged particles. Okay, so the radio waves, rather than reaching their destination, the radio waves, they get consumed here itself. And that is where you get the cross connection. If you are in Bengal, you get the radio waves of Bangladesh. North Bihar, radio waves of Nepal. Right? Punjab, radio waves of Pakistan. So that is why you experience these kind of cross connections. Okay. So that basically brings us to the end of this entire chapter, and that is where we will attempt this previous year question. Consider the following statements. Thickness of the troposphere at the equator is much greater as compared to the poles. At the equator, heat is transported to greater height by strong convectional currents. Which of the following is correct in respect to the of the above statement? So here, both the statements are correct, and the second statement correctly describes the answer of the first statement. Okay, so that is why the correct answer is A. There are other previous year questions also asked from this particular topic. That is something we will be discussing tomorrow before the class as a kind of a revision session. This brings us to the end of the session. I hope you have liked this session, you have understood this. In the MCQs, how many of them did you get it correct? Let us know in the comment section. And we meet again tomorrow. Till that point of time, do take care of yourself. Goodbye. Thank you.